Sorry about the mic. Anyway, alright, Gronks. Bit change of pace. Might see this box and think I'm doing a bloody PS5 review. I am not. This is just the biggest box, or not biggest, but biggest depth box. Well, it's not biggest, but it's perfect for the title, I guess. So, the lore. I need to remember what I did last year, and I also need to remember what I did earlier this year so I can remember it at the end of this year. So, physics. Last year, there was one test which I failed, which is somehow the easiest test for everyone else, but somehow I failed it. And then I did pretty well in all the other ones, so it's odd. So I'm just going to go through some stuff so I remember it for later, and maybe I help someone else out, I don't know. Anyways, physics. Motion. Alright, so I actually have done no revision prior to this. This is just me remembering. So I've got the ball is going up against can I focus that? Anyways, I'll just bring it up close so you can. Oh, it's blinded. Bloody hell. Oh, I can't read. My rig is a bit funky. Don't stress. Anyways, I'll just read it out. A 0.5 kilo ball moving at 8 meters a second hits a wall. Well, yeah, 8 meters a second hits a wall, and then 0.55 seconds later, it is moving at 3 meters a second in the opposite direction. So it's gone into the wall at that speed, bounced off, gone at that speed. So there's notes and whatnot from when I actually got this checked. So looks like here. Alright, just give me a sec. Right, we are back with a better understanding of the question, and for the most part, I'm just gonna read. Was the ball's change in velocity? So my dumbass decided to use the formula for the second question. Right, so change of velocity. Initial velocity. Fuck out this pen. Oh, okay. Initial velocity, u, is 8 meters a second minus 1, and then the final one is v is minus 3 because it's going backwards. Because ball is backwards. It's a negative velocity, so it's 3 meters a second minus 1. So then the change in the velocity is just final minus the initial, so that'd be minus 3 minus 8, which then equals minus 11. So the change is minus 11 meters a second to the minus 1. Question B. What impulse acts on the ball? So I don't know, but I'm just looking at this thing, so I'm assuming this is the formula. So the impulse equals mass times the final velocity minus mass times the initial velocity, and with that it equals because the final velocity is negative 3, we're gonna have 0.5 kilo ball, so 0.5 times negative 3 brackets minus 0.5 times 8 equals negative 1.5 minus 4, which equals negative 5.5 kilograms meters a second minus 1, or I think then here it seems to be like equals minus 5.5 Newton meters, or Newton seconds minus 1, because that's the units of the thingy. What force acts on the ball for the final one? Right, watch this. I'm just gonna. I've got no clue. Alright, we're back. So it looks like this. What force acts on the ball? It's the force that acts on it is because when the ball hits the wall and bounces back, right? That bounce back, there's a reaction force from the wall, I think, or something. Anyways, there's a force on the ball that's causing it to bounce backwards, of course. So it looks like here, this is so it looks like the impulse equals the force, so that's what we're looking for, times the change in time. So we have impulse from part B, so that's negative 5.5 equals force times 0.55 seconds, which is here. Now, so then if we rearrange this, so it'll be negative 5.5 over 0.55 equals the force. And then, oh yeah, nifty bugger. Calculator. Negative 5.5 divided by 0.55 equals negative 10. So then, which equals negative 10 newtons. That's that. Yeah. Physics. So, for the second part of this video, physics but tension. A truck is dragging 2 logs along level ground on a straight line. The mass of each log is 600 kilos, and each log experiences a constant retarding friction force of 400 newtons with the ground. The connections between the truck and the logs are made with ropes that have a braking force of 2800 newtons. T1, T2 are the tensions, bang bang. Truck and logs are moving towards the left, yep. Alright, watch this. Determine the magnitude of T1 and T2 when the truck is driving at constant speed. That's for the first question. Oh yes, okay. So, simples. This rope, I'll just stick with the black pen. This rope is trying to pull both this log and this entire mass, while this rope is only just trying to pull this one. So the tension on rope 2, T2, equals that 400 newtons there. 400 newtons. And then for T1, because this is pulling both this one and this one, 400 plus 400, 400 plus 400 equals 8. Yeah, so T1's 800 newtons total. Alright, then part B. The truck then accelerates this at a rate of 1.25 meters a second. To calculate the magnitude of T1 while this truck is accelerating. So T1, you remember, is pulling this entire mass because the rope joins them up. So, okay, here. The total mass of these 2 logs is just 600 plus 600. 600 plus 600 equals 1,200. Then, 1,200, and we have our acceleration times 1.25 equals 1,500 newtons. Alright. Okay. May not be correct with this one, might have to check the answers, but it looks like, because that net force, same, so it must be 1,500 equals the T1 minus 800, which is the force of these two things. 800 newtons there, so then 1,500 plus 800, so then it'll be T1 rearranging equals. Alright, that's physics. Hope it's physics. Sorry about the mic. Anyways, bye.